climate jerk is the technical term that might define our current environmental reality, referring specifically to the moment when acceleration itself begins to accelerate. It moves beyond the idea that things are simply getting worse or even getting worse faster. It suggests we have entered a phase where the very rate of change is spiking across multiple systems. When we look at the data coming in for 2024 and 2025, from record-shattering ocean heat to the disintegration of polar ice, the math points toward a positive third derivative. This isn't just about a warming planet anymore. It's about a system transitioning into a chaotic, non-linear regime where historical trends are no longer reliable guides for the future.
The physics behind this is actually quite intuitive once you get past the jargon. If you think about driving a car, velocity is your speed, acceleration is how hard you're pushing the gas pedal, and jerk is the rate at which you're moving that pedal down. If you're steadily flooring it, that's constant acceleration. But if you're slamming your foot down faster and faster, that's jerk. In climate terms, we've spent decades talking about the speed of warming. Then we move to acceleration, noting that the 0.18 degrees Celsius per decade warming rate since 1970 was picking up. But recently, specifically in data highlighted by researchers like James Hansen and the Potsdam Institute, we're seeing evidence that the acceleration itself is jumping.
You mentioned James Hansen, and he's been vocal lately about this acceleration of acceleration. His 2023 paper, Global Warming in the Pipeline, really set the stage for this debate. He argued that the rate of warming has effectively doubled since 2010, but he isn't just looking at surface temperatures. The argument for climate jerk relies on a convergence of indicators. It's not just one graph ticking up, it's a whole suite of independent systems showing the same signature of non-linear growth. Ocean heat content is perhaps the most alarming because it acts as the planetary radiator.
The ocean is essentially the Earth's thermal sponge. It absorbs over 90% of the excess heat trapped by greenhouse gases. A study published in the journal Nature in late 2023 and followed by data into 2025 shows that ocean heat uptake hasn't just continued, it has dramatically spiked. For decades, we saw a steady climb. But the transition from the pre-Argo float era to the current observation period shows the warming rate nearly tripled. In 2024 alone, we saw sea surface temperatures reach levels that weren't expected for decades. When the ocean hits these thresholds, it doesn't just stay hot, it starts to drive other parts of the system, like sea level rise, into their own jerk phases.
And the sea level data from 2024 is startling. NASA's Jet Propulsion Laboratory reported that global sea levels rose by nearly 0.6 centimeters in that single year. That's more than double the average annual rate from the early 1990s. Usually, sea level rise is a mix of two things: melting ice and thermal expansion, water getting bigger as it warms. Historically, ice melt was the bigger driver, but in 2024, thermal expansion suddenly accounted for 2/3 of the rise. It's like the system is shifting gears. If sea level rise is governed by a constant acceleration, we could plan for it. But if it's governed by jerk, the curve becomes much steeper, much faster.
That steepness is the defining characteristic of a singularity. In a jerk-dominated system, your future trajectory diverges from anything you've seen in the past. Take the ice sheets. For a long time, Antarctica was considered relatively stable compared to Greenland, but recent gravity data from missions like GRACE Follow On shows that Antarctic mass loss is accelerating at a rate of roughly 14 gigatons per year squared. Combine that with Greenland, and you have a total acceleration that's 3 times larger than what we see from mountain glaciers. The 2023 study in Nature Communications warned that we might be nearing an irreversible runaway effect, where ice sheets disintegrate at an exponentially increasing pace if we don't stabilize temperatures below 1.8 degrees Celsius.
It seems there's a feedback loop here that researchers are just beginning to quantify. As the ice melts, it doesn't just raise the water level, it changes the ocean's chemistry and its ability to circulate. This leads us to Rossby waves, those giant meanders in the jet stream. If the temperature difference between the poles and the equator shrinks because the Arctic is warming 4 times faster than the rest of the planet, a phenomenon called Arctic amplification, those waves start to stall and grow larger. This isn't just a weather change, it's a structural shift in how the atmosphere moves heat. When these waves become persistent, you get the heat domes and stalled floods that have become so common lately.
There's a lot of debate in the atmospheric science community about this right now. Some researchers, like those at Harvard in 2026, have cautioned that the theory of quasi-resonant amplification, the idea that these waves are getting trapped in a specific way, might be harder to prove than we thought. But even with that scientific caution, the observational evidence of atmospheric blocking is hard to ignore. We're seeing more instances of weather systems simply getting stuck. This persistence is another sign of a system losing its ability to return to equilibrium. It's moving away from a linear, predictable state into something much more erratic.
So, if we step back and look at the big picture, we have ocean heat content tripling its rate of increase, sea level rise doubling its rate since the 90s, ice sheets losing mass at an accelerating pace, and atmospheric patterns becoming more extreme and persistent. If each of these systems is showing acceleration, and that acceleration is itself increasing, the jerk isn't just a mathematical curiosity. It's a signal that the Earth system is transitioning toward a new regime. The question is whether our current models even account for this. Most climate projections use linear or quadratic extrapolations. They don't handle jerk well because jerk implies the parameters themselves are changing.
The models are actually at the center of a very heated internal debate. Many mainstream models, like the CMIP6 ensemble used by the IPCC, do project some acceleration, but critics like Hansen argue they are too conservative because they don't fully capture the darkening of the planet. As we clean up air pollution, specifically sulfur aerosols from shipping, we're removing a mask that was reflecting sunlight. This unmasking provides an extra kick to the system, a sudden increase in the energy imbalance. That sudden change in forcing is exactly what creates jerk. It's a shock to the system that triggers these nonlinear feedbacks.
This idea of unmasking is fascinating and terrifying. It means that by doing something good, reducing toxic air pollution, we might be inadvertently triggering a spike in warming. It highlights the sheer complexity of the planetary energy balance. If we increase the CO2, we add a force. If we decrease the aerosols, we remove a counterforce. Both lead to a positive third derivative in temperature, and as the temperature spikes, it hits those tipping points in the ice sheets and the permafrost, which then release more gases, creating even more jerk. It's a cascading series of acceleration.
It's why the term singularity is being used more frequently. In mathematics, a singularity is a point where a function becomes infinite or well-behaved laws break down. While the Earth isn't going to have infinite temperature, the breakdown of predictable laws part is very relevant. If we are in a regime of climate jerk, the historical record from the last 10,000 years, the Holocene, is no longer a valid baseline. We are entering uncharted territory where the rules of the climate are being rewritten in real time by the feedbacks we've triggered.
We can see the physical reality of this uncharted territory in the coastal data. The Woods Hole Oceanographic Institution found that sea level rise along the U.S. coast has more than doubled since 1900. But the kicker is that the rise in 2024 was significantly higher than what the federal reports from just a few months prior had predicted. When the data consistently outpaces the projections, it's a clear sign that the acceleration parameter in the model is too low. We aren't just moving fast, we're speeding up our speeding up.
Implications for infrastructure and planning are massive. If you're building a seawall or a drainage system based on constant acceleration, you're likely to be underprepared within a decade. A system with positive jerk means that the worst-case scenario of today becomes the likely scenario of tomorrow. This is why the distinction matters. It's the difference between a problem you can manage with gradual adjustments and a crisis that requires a total rethinking of how we interact with the environment.
And it's not just the oceans. The atmospheric circulation changes are bringing this jerk into our daily lives through climatic whiplash. We see it when a region swings from a record-breaking drought to a catastrophic flood in a matter of weeks. The energy in the system is so high and the circulation is so destabilized that the transitions are becoming more violent. The Potsdam Institute's 2026 findings confirm a strong and statistically significant acceleration of warming since 2015. They removed the noise from El Niño and volcanoes, and the signal that remained was a sharp upward curve.
That removal of noise is crucial because it answers the skeptics who say 2023 and 2024 were just anomalies caused by a strong El Niño. When you strip that away, the underlying trend is still accelerating. The energy imbalance, the difference between the energy coming in from the sun and the energy leaving the planet, is at an all-time high. This imbalance is the force in our F equals ma equation. If the force keeps growing, the acceleration keeps growing. That's the definition of jerk.
It feels like we're describing a planetary-scale runaway train. If the climate jerk is already underway, what does that mean for our ability to hit the Paris Agreement targets? Stefan Rahmstorff from the Potsdam Institute mentioned that if the current rate of warming from the last decade continues, we'll blow past the 1.5-degree limit permanently before 2030. Not as a temporary spike, but as a long-term exceedance. The window for a linear transition to net zero seems to be closing because the climate isn't waiting for our linear policy cycles.
The 1.8-degree threshold mentioned in that Nature Communications study is another critical marker. Beyond that point, the disintegration of the West Antarctic ice sheet might become irreversible due to those coupled feedbacks, where the melting ice changes the ocean, which then melts more ice. We are essentially poking a complex, interconnected beast with a very large stick, and the beast is starting to move much faster than we anticipated. The jerk is the signal that we have lost control of the pace.
It's a sobering realization that our observational tools, the satellites, the Argo floats, the tide gauges, are all screaming the same thing. The convergence across independent domains is what makes the jerk hypothesis so compelling. It's not a fluke in one dataset. It's the integrated response of the entire Earth system to an unprecedented thermal shock. We've moved from the era of global warming to global heating, and now, perhaps, to the climate singularity.
And the challenge for the scientific community now is to bridge the gap between these observations and the public's understanding of risk. If people think the change is going to be steady and predictable, they won't feel the urgency. But if they understand that the rate of change is itself exploding, that we're in a jerk regime, the math of the problem changes. Every year of delay doesn't just add a year of warming, it adds an increasing amount of acceleration to the disaster.
Ultimately, the evidence for climate jerk serves as a final warning that the Earth system is nonlinear and highly sensitive. The data from 2024 and 2025 across ocean heat, sea levels, and ice mass isn't just a series of broken records, it's a fundamental shift in the system's momentum. We are witnessing the birth of a new climate regime, one defined by acceleration of acceleration, and our survival may depend on how quickly we can adapt our thinking to this new, chaotic reality. Share this episode with someone who needs to understand why the speed of climate change is shifting into a new, more dangerous gear.